This is Euclid Book 10, proposition number 89. And we're going to be finding the fifth epitome. Let a rational straight line A be set out. Well, there's A right there. And let CG be commensurable in length with A. Okay, so CG is commensurable with this. Therefore, CG is rational. This is a rational line here. Let two numbers, DF and FE, well, DF is one number right here, and FE is the other one, be set out such that DE again, okay, so DE, right here, has not to either of the numbers DF, okay, so DE does not have to DF, nor does DE have to EF, okay, the ratio which a square number has to a square number. And let it be contrived that as EF is to ED, as EF is to DE right here, okay, so as EF is to this whole thing, so is the square on CG, that's this one right here, to the square on GB, that's this one right here. So, we're now forming a ratio. You're going to do this, okay? So as this short line is to this long line, so is this to that. Therefore, the square on BG is also rational. This is a rational area. Therefore, the line BG is rational. Now since, as D is to EF, as DE is to EF, so is the square on BG the square on CG. As this is to this. While DE has not to EF the ratio which a square number has to a square number. Okay, we've already established that. Therefore, neither has the square on BG have to the square on CG, this does not have to this, the ratio which a square number has to a square number. Therefore, the area of BG is incommensurable. Well, okay. Never mind. Let's try this again. Alright. As this does not have to this a ratio which a square number has to a square number, then we can say that this length right here is incommensurable with this length right here. Okay? This is not commensurable with this. This is by Euclid Book 10, proposition number 9. Now, this line and this line, they're both rational. Therefore, these two lines are rational, and they are only commensurable in square. Therefore, BC is an epitome. I say next that it's a fifth epitome. Now, how are we going to prove this? For let the square on H, well, there's the square on H right there, be that by which the square on BG is greater than the square on GC. Okay, so what does that mean? What that means is that if you add this area to this area, you'll get this area. That's what it means. Since then, as the square on BG is to the square on CG, so is DE to EF. Okay? So as this is to this, so is this to this. Therefore, convertendo, as ED is to DF, as this whole length here is to this, so is the square on BG is to H. Okay? And this is by Euclid Book 5, proposition number 19, porism. But ED has not to DF, okay? This does not have to this the ratio which a square number has to a square number. Therefore, neither has the square on BG to the square on H the ratio which a square number has to a square number. Therefore, the length of BG, which is this length right here, is incommensurable with the length of this. That's by Euclid Book 10, proposition number 9. And the square on BG right here, is greater than this square right here by this. That means that if you add these two areas together, you get that. Therefore, the square on BG is greater than the square on CG by the square on a straight line incommensurable in length with GB. Okay? This is bigger than this by this. And the annex CG is commensurable in length with the rational straight line set out. This is commensurable with this. Therefore, BC is a fifth apotome. And now we found it. Alright. I will tell you more in my next video, so I want you to stay tuned.